Now we're going to take a look at the properties of logarithms. Remember that logarithms are based on exponents, so the rules of exponents apply. So when we're multiplying, we add our exponents, and when we divide, we subtract our exponents. So the same rules are going to apply here. For all positive numbers, m, n, and b, where b does not equal 1, the log base b of m times n is the same thing as the log base bm plus the log base bn. So here you're seeing the multiplication become addition. And then the other property is the log base b of m divided by n is equal to the log base b of m minus the log base b of n. I'll give you a minute to get that copied down, and then we're going to do some examples. Okay, let's take a look. For the first example, we have log base 6 of x plus log base 6 of 9 equals log base 6 of 54. Okay, so we have addition, so how can we rewrite that? That's right, we're going to rewrite it using multiplication. So here on the left-hand side, we're going to write log base 6 of x times 9 is equal to log base 6 of 54. And then you can rewrite it if you want as 9x. But now that we've narrowed it down to only one log on each side and the bases are the same, we can drop those logs. So we're going to have 9x is equal to 54. I'm solving for x, so I need to divide both sides by 9. And x is equal to 6. And remember, we always have to plug our answers in to be sure that they work. When I plug a 6 in here, that's fine because it's going to be positive. And then when we do the multiplication, 6 times 9 will give us 54. So the answer is x equals 6. This next example uses the subtraction. We have log base 8 of 48 minus log base 8 of x is equal to log base 8 of 4. So subtraction becomes division. So on the left-hand side, I will have log base 8 of 48 divided by x equals log base 8 of 4. Now that I've narrowed it down to one log on each side, and they have the same base, I can just drop them, and I will have 48 over x. 48 over x is equal to 4. And I'm solving for x, so I'm going to need to multiply both sides by x. So these will cancel. I'm going to have 48 equals 4x. And then when I divide by 4, I'm going to get x is equal to 12. Again, be sure to check your work, and 12 works. So we're good. X is equal to 12. Okay, here are two for you to try on your own. We'll start with this first one. Log base 4 of x plus 3 is equal to log base 5. I'm sorry, did I say that wrong? Log base 5 of x plus 3 equals log base 5 of 8 minus log base 5 of 2. So I'm going to give you a few seconds to try this one on your own. Don't forget, subtraction becomes division. So we're going to get the log base 5 of x plus 3 is equal to the log base 5, and this is division because it's subtraction, of 8 over 2. 8 divided by 2 is 4, and we can drop our log, so x plus 3 equals 4. Subtract 3, so x is equal to 1. When you come and you plug 1 back in, you're going to have 1 plus 3, and that's 4, and that's fine. So your answer is x equals 1. The next one for you to try is going to be log base 3 of 14 plus log base 3 of x equals log base 3 of 42. Okay, so for this one, because we have addition, that becomes multiplication. So that's going to be log base 3 of 14 times x equals log base 3 of 42. We've narrowed it down to 1 log on each side, so we can drop them. So 14x equals 42. Divide by 14, and x is going to equal 3. When we plug 3 in for x here, that's fine. So our answer is x equals 3. And the third property of logarithms is called the power property. For any real number p and positive numbers m and b, where b does not equal 1, the log base b of m to the p equals p times log base b m. So basically, you can bring that exponent to the front, and it becomes multiplication by that number. Okay, let's take a look. Here, it says solve for x. Log base 7 of x equals 2/3 log base 7 of 8. So this is kind of going in reverse of the property. We've got 2/3 right here in front, and we know that by the power property, I can bring it up. So this is going to be log base 7 of x equals log base 7 of 8 to the 2/3. As a little side note, 8 to the 2/3 is the same thing as saying the cube root of 8 squared. The cube root of 8 is 2, and 2 squared is 4. So that means that I have the log base 7 of x equals the log base 7 of 4. And because I've narrowed it down to 1 log on each side, I can just say x is equal to 4. For this next one, I have 4 times log base 8 of x equals log base 8 of 81. I can bring this 4 to the exponent of the x and have log base 8 of x to the 4th equals log base 8 of 81. I can drop the logs on both sides and say x to the 4th equals 81. Now we're going to take the 4th root of both sides to cancel the x to the 4th. The 4th root tells us that we're expecting to get how many answers? 4. 81 is going to be 9 times 9. which is 3 times 3 and 3 times 3. So we know that 3 is a solution. We also know that negative 3 is a solution. However, if we took x to the 4th equals 81 and solved for 0, we would get x to the 4th minus 81 equals 0. And then we can do our factoring. So we'd have x squared plus 9 times x squared minus 9. And then here we could factor the x squared plus 9 times x plus 3 times x minus 3. And we can set each one of these equal to 0 to solve. So here we know negative 3. Here we're going to get 3. And then when you solve this one, you're going to get x squared is equal to negative 9, which means x is equal to plus or minus 3i. So there are 4 possible choices of answers. However, logarithms deal graphically, and so we know that imaginary answers are not possible solutions. And we also know that if we plug the negative 3 in here at the beginning, we can't take a log base 8 of a negative number. So the only solution is the positive 3. So the imaginaries were not answers because this is graphing and it has to be real solutions. And if we plug negative 3 back in at the original, we know that 8 to some power will never equal a negative number. 8 to some power will never equal a negative number. And you always have to check your answers back at the original. Okay, here's our next one. We've got the log base 5 of x minus 12 plus the log base 5 of x plus 12 equals 2. If you notice, what's different about this one is there is not a log base 5 on the right-hand side of the equal sign. So we're just going to have to start with our properties and see what happens. We have addition, which means that this is going to become multiplication. So that is log base 5 of x minus 12 times x plus 12 equals 2. Well, I'm now in logarithmic form, which means I could switch it back to exponential form. An exponential form would be 5 squared equals x minus 12 times x plus 12. From here, I'm going to have 25 equals x squared minus 144. I can subtract the 25, and I'll have 0 equals x squared minus 169. And then to factor that, that's going to be 0 equals x plus 3 times, 13. X plus 13 times x minus 13. And when I set each of those equal to 0, I'm going to get x equals plus or minus 13. Now, when I plug in a positive 13, 13 minus 12 is 1, and that's fine. 13 plus 12 is 25. So positive 13 is a solution. However, negative 13 minus 12 is going to give me a negative 25, and 5 raised to a power will never equal a negative 25. So my answer is 13 with an extraneous root of negative 13. Okay, here's one for you to try yourself. Log base 10 of x equals 1/2 log base 10 of 81. So give that one a try. here we have the 1/2 out in front, which we know is going to come up here and be an exponent on the 81. So I'm going to have log base 10 of x equals log base 10 of 81 to the 1/2. 1/2 as an exponent means to take the square root. So the square root of 81 is 9. So I'm going to have the log base 10 of x equals the log base 10 of 9. So x is equal to 9. When I plug that back in, that works. The next one for you to try is log base 6 of x equals 3/2 log base 6 of 9 plus log base 6 of 2. And for the second one, we have the 3/2, and that'll be the exponent on the 9. So that's going to be log base 6 of x equals log base 6 of 9 to the 3/2 plus log base 6 of 2. And again, we have addition, so that's going to become multiplication. But before I do that, I'm going to do the 9 to the 3/2. 9 to the 3/2 means the square root of 9 cubed. The square root of 9 is 3, and 3 cubed is 27. So over here we're going to have log base 6 of x equals the log base 6 of 27. And then remember, the plus sign means multiplication, so 27 times 2. And here I've narrowed it down to 1 log on each side, so I can say x is equal to 54. Here's your next one. Log base 7 of 3x plus 5 minus log base 7 of x minus 5 is equal to log base 7 of 8. Okay, here we have subtraction, and that means that's going to become division. So this will be log base 7 of 3x plus 5 over x minus 5 equals log base 7 of 8. And because we're narrowed down to 1 log on each side, I can just rewrite that as 3x plus 5 over x minus 5 equals 8. I'm hoping nobody tried to cancel the 5's because everything is held together by addition and subtraction. So we can multiply both sides by x minus 5. And that's going to give me 3x plus 5 equals 8x minus 40. Subtract the 3x from both sides. You'll get 5 equals 5x minus 40. Add the 40, which will be 45 equals 5x. And then divide both sides by 5, and you'll get x equals 9. Be sure you check your answer. The 3 times 9 plus 5 is going to be 27 plus 5 is 32, and that's great. And 9 minus 5 is 4, and that's great. So we are good there. Okay, guys, I'm going to work just a couple more problems as practice, and then you're going to be on your own for your homework. Okay, I would like you to express the log base A of x cubed square root of y over z squared in terms of x, y, and z. So what I'm asking you to do is expand it as much as you can. I've got it compacted. You're to expand it. To start expanding this one, you need to notice that the numerator is multiplication, and then, of course, we have division for the z squared. So I'm going to start off with the division. So that's going to be log base A of x cubed square root of y minus log base A of z squared. Then, for this first part, I've got multiplication, so I can write that as log base A of x cubed plus log base A of the square root of y minus log base A of z squared. And then the last thing that needs to happen is all of our exponents can come to the front. So this is going to be 3 times the log base A of x plus. Now, the square root of y is the same thing as y to the 1/2. So I'm going to have plus 1/2 log base A of y minus 2 times log base A of z. And that will be my final answer. That's it fully expanded. Okay, solve this. Log base 2 of x plus log base 2 of x plus 2 equals 3. So solve that for x. Okay, let's take a look. We have addition here, so this is going to become the log base 2 of x times x plus 2 equals 3. I'm noticing I do not have logs on both sides, so I'm going to have to try to rewrite it in exponential. So this is going to be 2 cubed equals x times x plus 2. Now, 2 cubed is 8. Distribute the x, so that'll be x squared plus 2x. Since we're trying to solve for x and we have a quadratic, we have 4 ways to do that, but we always set it equal to 0 first. So we're going to have 0 equals x squared plus 2x minus 8. So try to factor it. What are the factors of negative 8 that add up to 2? That's going to be 4 and negative 2. So I have x plus 4 times x minus 2 equals 0. So x is equal to negative 4 and x is equal to 2. And again, come and check your work all the way back at the beginning. And if you try to plug in negative 4, that'll leave you with the log base 2 of a negative. So that is not a solution. So our answer is going to be 2 with an extraneous root of negative 4. Okay, guys, your homework's going to be page 415, number 17 through 65, every other odd. Be sure to show your work because I know these are odds and you can copy them out of the back of the book. So you're going to need to have your work to get credit. I hope you all have a great day, and I will be seeing you soon. Thanks, Miss Banna.